Okay, in this short video, I wanted to discuss how to integrate in the integral of x to n log x to n, where m and n are integers. Actually, we only, as long as n is a positive integer, this method will work. Now, we could use the typical way by using integration by parts, where u equal to the log term, and the dv is the power function times dx. And we will work on this specific example to illustrate the the idea here. Now this method is going to be long, and we have to use integration by parts multiple times. So we will use another method, which is a substitution first. It's going to convert this integral into something more familiar, and we can use the so-called tabular method, which is really efficient and more importantly, it's kind of error-proof. So the substitution here is this: we're going to let u be log of x. So this is for substitution, not for integration by parts. Now, if u equal to log of x, then x will be e to u. So we can convert the power term. Also, dx will be the derivative of e to u, so it's e to u times du. So now we can easily convert this one. Again, we're going to work this specific example. So x squared becomes e to u squared, right? Log of x cubed becomes u cubed, and dx becomes e to u du. So the integral now becomes u cubed e to 3u du. So this is the integral of the product of polynomial and e to 3x. And we can use the tabular method, which we know is really efficient. So let's go to the next page here. So the integral we end up with is integral of u cubed e to 3u du. So now remember the tabular method, which works really well for the integral of a product of polynomial and exponential function. So we are going to create a table where the first column is u cubed, second column is e to 3u. And now we take a derivative first factor, we get a 3u squared. Second derivative, get a 6u. Third derivative is 6. Fourth derivative is 0. And then for the second column, we need to integrate e to 3u with respect to u, successfully. And so we know the formula. Let's get a 1/3 e to 3u. Integrate again, 1/9 e to 3u. 1/27 e to 3, and 1/81 e to 3u, right? So now by the formula that we learned, we are going to form those 4 diagonal products. So we get the integral u cubed e to 3u du is going to be u times 1/3 e to 3u. That's the first product. And then minus 3u squared 1/9 e to 3u, and plus 6u times 1/27 e to 3u, and then minus 6/81 e to 3u plus c. So now again, that's the answer for this integral. Now we're going to simplify this. We notice that e to 3u is a common factor. Let's take it out. The e to, yeah, I'm sorry, this is a u cube here. So e to 3u, and then it's 1/3 u cubed. And the second term here is 1/3 u squared. And the third term here, it's 6u, 6/27. We cancel 3. We get 2/9u. The last term, 6/81, and we can cancel 3 from the numerator and denominator. We get it 2/27 and plus c. Okay. Oh, I forgot to mention that in the previous step here, we have 4 terms, 4 diagonal products, and we needed to combine those 4 products with the plus minus. That's why we have, you know, 2 second and fourth term are negative, and first and third term are positive. But this is the answer here, and now we're going to change it back. So we get remember our original integral is x squared times log x cubed, which is equal to what? This is the integral of u cubed e to 3u, right? And we got you know, this answer. So we needed to convert it back, you know, we're going to replace u by you know, log of x. So we end up with, for example, e to 3u becomes e to 3 times log of x, which is e to log of x cubed, which is x cubed. You know, earlier we you know, we noticed that e to u is the same as x. So e to 3u becomes x cubed. And then for the u is the log of x. So with the log of x cubed minus 1/3 log of x squared plus 2/9 log of x minus 2/27 and plus c. So this becomes the, you know, the answer, and it's much simpler. You know, the original solution, you know, given by the book is, if you write it on here, it's going to be at least 3 pages. Okay. Well, hope you enjoy that, and notice that this just demonstrates that often there are more than one way to solve a problem. Some might be easier, some might be simpler. So, you know, of course, first we wanted to find at least one way to solve it. But when you have, you know, tried the different methods, and then you can see sometimes you may have a method that's much, you know, quicker, much shorter. Okay, that's all for today.